Hello everyone. So let us start with the composite design pattern in this video. So let us understand what a composite pattern is, and then we will take an example of a file system to see how we can implement it. So what is a composite design pattern? It allows you to treat the group of objects as a composite and single object as leaf in the same way using a common interface. That's an important line, that it should be a common interface. So it is mainly to represent a tree-like structure. So if you would assume a tree in front of you and you want to create that tree from different classes, then there are certain leaf nodes, there are certain intermediate nodes as well, and a root node. So all these classes can be different. But if you want to have some functionality which can recursively call into a tree format, then you have to have a common interface so that all of the classes will be implementing those functions and can use those functions to call inside a tree-like structure. So that is the main purpose of using the composite pattern. So we can use it like in file system or UI element or menus. So let us take an example of file system itself and let us try to implement it. We'll try to print how the file system can be represented. So let us go to Visual Studio and we'll create of files. Okay, let us name it the composite.cpp. So we are looking at composite design pattern. Hash include iostream using namespace std. Now I'll create an interface called file system item, which will be having a method called show, and I'll recursively call onto the show method, which will print all the directories. We are going to implement this functionality. So let us name it component class file system item, and we'll be having certain virtual methods. Virtual void show. I'll just pass an argument called intent, or let us name it properly. It will be indent. We'll have a default argument and it will be a pure virtual method. Virtual will be having a destructor file system item. Now we want to have a leaf node. So class, let us name it file, the smallest component, public file system item. Now we are going to have certain name of that folder. So we'll keep it in private, string name. Then in public section, we are going to override the show method. Before that, we'll be having a constructor, which will take a string in, let us say, name, and we'll assign it using the initializer list. After this, we have to override the show method, which will have an int indent. By default, let us keep it 0. Override. We'll just see out the name of the file. So whatever is the indent, I'll just say string indent, and instead of space, let us make it hyphen. So this, whatever the count of indent is, that many times I should print a hyphen, and then the file. Okay. And after that, the name. Right. With this, the leaf is completed. After this, we want to composite, which is the intermediate nodes. So you can say that. So let us name it composite. Class, there will be a folder. A folder can consist of subfolders as well. It can consist of files as well. So it will also implement public file system item. So you can see the same interface is being used everywhere. Now here you will be having a name of the folder. Apart from that, your folder might contain a number of files and folders. So what we have to do is we have to just create a vector of file system item pointer. Let us name it items. Whatever items it will be consisting. Public. So for vector, I have to include the library hash include vector. Now in the public section, first of all, we have to create a constructor which will again take string n, which is name, and I'll just assign the name to n to name basically. Then there will be a method called add. So this add method will have an argument which will be a file system pointer, say item, and we are just going to push it inside the vector, pushback item. So we can add any number of file or folders inside the current folder. After this, we have to override the show method, void show int indent will be there in the argument. Now let us also keep it override. So in this cout, we are again going to use the string indent. Whatever indent is there, just print that number of times the hyphen. After that, print folder. Okay. And then the name. Once this is done, the list has to be traversed. So for auto, let us name it item. In items, I will go on to each and every subdirectory or file, whatever is it inside the item, and I'll just say item of show. So show function will be called on the item, and inside that I'll just pass indent plus 2. So my current is 1 hyphen, then 2 hyphens will be added for the next directory to be printed, and it will be recursively called. Now let us see if I'm going to have an int main and I'm trying to print the folder structure, then how will it be printed? So folder pointer, let us name it root equals to new folder, and we'll name it root. After that, root of add, I'll just add new file into it. Now this file I can name it as file1 dot say text, and let us add another file, new file, and we'll name it file2 dot text. Right. Let us also create a new folder, subfolder equals to new folder, and we will name it, let us say, document. Right. And let us also insert some files inside the subfolder as well. So my subfolder, add new file, and we'll name it doc1.txt, and let us say subfolder of add new file doc2.pdf. right? Now root of add, and I'll just add the subfolder inside my root directory. Right. Now let us try to print root of show, and let us see how does the indent work. So now you will understand why the indent has been incremented twice. So let us try to compile it and see if there are any errors. Then G++, Composite. Yeah, let's name it comp. So we got an error. Okay, at line 37, we got an error that we missed the semicolon over here. Let us save it and let us try to compile it again. So it compiled successfully. Let us try to execute it. So you can see the root directory got printed. Then we have two files. So both of them got two hyphens and they got printed. Again, the folder is also having two hyphens and it is also there in the root directory. After that, we have two more hyphen being inserted, and the folders and the folder which is document, inside that we have doc1 and doc2. They are printed with two hyphens. So in this way you can like differentiate which folder consists of which file. So that is why we added indentation of incremented by 2. So this is the way how the composite pattern is used. It is just to represent the structure in a tree format so that you can have a recursive call, and that is the main purpose of using it.